Hello, good morning. Thanks so much for coming and keeping me company here in my shop while I go the next step with this receiver, this one channel working receiver. Why is only one channel working? So by doing some signal tracing, I found both channels present at the volume controls in here, and then at the balance control I found one channel missing. So somewhere between the volume control and the balance control, a small portion of the circuit in the amplifier, somewhere in there lies the problem I'm after. So one thing I didn't do is make a simple observation about which channel it is that's quiet, so I know which part of the circuit board has the defect in it. So I'm going to repeat the last test, sort of reprove that one channel is dead at the balance control. We just take a glance at the schematic here, and I know it's there. It's better this way. So that's the amplifier, that's one channel, that's the other channel. These are the inputs. The outputs come out here, fiddle around in a switch, and go to the speaker. The volume control is located right here in this area somewhere. I can't spot it, but it's right in here. Signal there, both channels. Tone control is located, not tone control, balance control is located right here. By the time you get here, only one channel. In between, two transistors and a bunch of parts. Take a wild guess at this point. Defective transistor. Wild. That's not a wild guess. That's a guess. That's a educated guess. So we're going to turn on. That's an informed guess. Okay, we're going to turn on the power here. You can hear a little bit of sound coming out of that speaker. This speaker you can't see is dead. Let me turn it up a little bit. That's the AM radio. I'll turn the balance control. That's all the way in favor of this channel. You don't hear a thing. And that gives you a little bit of an idea how high the volume really is set. Very, very high. Very high. So I have clip leads connected. This green and white clip lead are connected to the two outside terminals of the balance control. The center terminal goes to the chassis. So this balance control, as you operate it back and forth, it's just choosing which channel to waste some signal, or to throw some signal away on, and that's how it achieves the balance. A bit unusual. So I'm going to flip on my signal tracer here. And it's connected right now to the green clip lead. So we should start hearing stuff. Or maybe not, depends. I can't remember which channel was the noisemaker. I'll turn up the tracer. Nothing there. Okay, we'll switch now to the other. And there it is. So we know the white one is the working channel, green one is the dead channel. Now wait a second. Just be sure. I'm gonna move the. There's a DC voltage causing that crashing sound there. I'm gonna turn the balance control just to make sure I'm not fooling myself somehow. Maybe I am. Good thing I repeat these tests. Looks like I made a mistake. Looks like both channels are present. Let me put this. Okay, so the balance is roughly in the middle now. Wait a minute. We're not listening. We're listening to the wrong thing here. Oh, I must have the volume up a little bit. Right. Okay. Turn the volume up on the tracer. Maybe it's just too quiet. Okay, it's up pretty high. Look for a thing. coming out of that. Hey, what's going on? I'm not sure why we can't hear that coming out of the signal tracer. Okay, let me work the balance control here. I'm going to turn the volume down a little bit. Okay, and the balance control. Hey, what's happening here? Hey, what has happened? I hear it now. I can hear it a little bit. Hey, let's do this. There's a switch here. I can switch the speakers off. Getting confused about which speaker I'm listening to. Okay, so all we can hear now is the signal tracer. Volume up and down. Okay, only the tracer. Now I'm going to work the balance control here. Since balance control, I'm going to put it in the middle. Okay, that should be the middle. One channel, one side. How do you like that? Okay, so I just proved myself wrong. Both signals are present at the balance control. I believe what was happening was I'm turning that balance control off the center, and what it's doing is it's just bleeding down one channel to the point where you can't hear it on the tracer. Fooling me. Okay, so the signal is there at the balance control. So that's actually, you know, I'm really expecting the trouble to be in the final transistors. That's really what I'm figuring on. So I want to come forward a little bit further. Right now we are listening right here, just before these two transistors. Is there an easy thing to pick off going forward? So I'm looking for some kind of component I can spot easily in there. Now there's a fairly large capacitor here. The signal has to go, it's got a number of capacitors it's got to pass through. Should probably step our way through it one at a time. And I don't know which channel's the dead channel at this point. I have to work my way through both. That's crazy. Let's jump to the end. Find out which of these channels is the dead one. So I'll try to pick the output off. I believe it's right here. There's a capacitor. And then from there it's into the switch and out to the speaker. So I think this is the output transistors here. You know what they've got? They've got push-pull here, I believe. It's push-pull. Could it possibly be push-pull drive? I'm not sure what's going on here. Not sure how they've done this, but looks like this guy drives this guy, and this guy drives this guy. And these two may be operating essentially in series. I'm not sure. I'm not sure what's going on. I am not sure. With push-pull, I think you need a transformer to recombine to go to the speaker. No, this is a transformerless amplifier. Because it has no output transformer, it stands a chance of having higher quality sound than it would. Okay, so that's the idea. Find these capacitors. Okay, find those capacitors. I'm going to stick the schematic up on the screen. We'll look closely at it here. Okay, here's the schematic. Let me just turn down the signal tracer here. The part we're interested in now is down in this area here. So I found the signal out here, and I found it again Here's the balance control. See the word balance? And I found the signal here and here. So we should, we could start stepping over top of each individual component here and working our way along, but I want to jump to the end and figure out which channel it is that's dead. So I'm thinking finding these is probably easy because they're probably the biggest capacitors in there. It says 1000/38. 38 maybe a voltage or something like that. I'm not sure what that is. 1000 though is fairly large, and it's going to be on the end of the board. Hey, you know what? C7, C8, end of the board. There's diagrams. There's board diagrams here. Okay, so component side of the what? Of the AM/FM board. This is the audio board here. We're coming in this way. Looking for the balance control just to get myself started here. I don't see it here. Of course, I've got the image of the schematic in my head. That's okay. Q101, 102, 107. These are numbered the other way. These are numbered. This is component side of the board. It'd be like looking down on the board. This really doesn't resemble the schematic at all. Oh, wrong board. Here we are, audio board. 06, 05. And what was the number? Just look on the piece of paper here. I'll remind myself. The number of the it was the size of the capacitor. The number of the transistors is 1, 2, 3, and 4. 1, 2, 3, and 4 appear to be all output transistors. 1, 2, 3, and 4. 1, 2. Oh yeah, and 3 and 4 would be the other board. Right. This is only half the board. They're only showing half the board. Only showing half the board? Really? It's not two boards. It's one physical board. Why would they only show? That's interesting. 30 volts. I haven't noticed that before. Do they have any feedback left? That's interesting. Feedback right. Okay, so the feedback is a technique used to reduce harmonic distortion at the output. They just feed a little bit of the speaker signal back into the amplifier, and it sort of generates a difference voltage. It's really not quite the right way to look at it, but you can think of it that way. It's an error voltage that corrects the front end for what's coming out of the back end. I mean, there's a logical problem with what I just said, but you can think of it that way. Okay, so we don't be concerned about that. Where are those big capacitors? Where are those big capacitors? Nowhere's around here. 6.4. What are these? Okay, so this would be like the volume control coming over, and it's a two controls, piggyback. So one control, another control. Volume. Here's the tone. Now wait a minute. Is this showing both channels then? Sure, it's showing both channels. Oop. Channels, 20 volts. That's interesting there. 101, 102. Where's 103? 103. And then there's 104. 104, way over here. So I'm stunned here because I'm just expecting this to be in a pattern, not unlike the schematic. I would expect these 4 transistors to be in a nice pattern, but there's no pattern here. There's no pattern. Okay, so can we spot now? Well, look here. Well, that's a 25. I'm looking for something bigger than that. I'm looking for anywhere in here now. Show me 100. Was it really 100? I'm going to look again on the schematic because maybe I have a tendency to make stuff up. 1,000. That's a big 1,000. And what's it hooked up to? Yeah, not that easy. It's hooked up to stuff. So there's 1,000 in here somewhere. You've already found it, and I haven't. Two 1,000s. They should be just kind of tucked in here somewhere. They're showing on the board. This transistor here, 104, hooked up there, hooked up there. Well, maybe this is it. On the schematic, it's a 25. On the schematic. What am I saying? On the schematic, it's 100. On here, it's 25. It just doesn't seem possible. It's the same document. So what is going on here? What is going on? Oops. There, that helped a lot. Right here. It says 1,000. C7. There's a parts list, isn't there? Parts list is above. Parts list is above. A C7. Where's the numbers? Oh, over here. See, oh man, there's a lot of them. Do you see a C7 in here somewhere? These have all got 3-digit numbers. So you're indicating what board they're on by using the prefix number. Something like that's going on. Oh my gosh. Looking at this sideways killing me too. Okay, resistors, 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 AM, FM, trim, loudspeaker, loudspeaker, AM, FM printed board assembly. Oh, there's more to it here. Front panel assembly, left side panel assembly, right side panel assembly, front panel assembly, center panel assembly, audio printed board assembly. This must be it here. Here's all the transistors. Here we are. So we have capacitors. There's nothing with 1,000 written on it. 1,000 anything. 250 volt capacitors. 500 volt. What are they doing with all that? Such high ratings. It's possible, you know, ceramic capacitors, that's the way they came back then. They were all rated high like this. Well, so these are the electrolytic capacitors that appear on the board, and their numbers are legion. Okay, what is the number again of the capacitor I am interested in? Holy smokes, what a runaround this is. C7 and C8. Do you see 7? Do you see? Well, there's no, they're not numbered. Well, here they're numbered, just 2 digits. Well, maybe it's 107 and 108. So can I find a C8, a C108, a C108? Nothing like a 0.1. A 0.1 is 100. I'm just trying to find out where the number 1000 comes from. On here. Oh my gosh, how silly is this? Crazy situation. The simplest things can become just mind-boggling here. I'm going the wrong way. That's what's happening. Definitely going the wrong way. Well, what are we going to do here? I can't find this capacitor. Over here. Here, this guy. Well, what else could I find? So, well, like this capacitor has to be connected look at it, it's connected right to the output here. Same thing here, or input, whatever it is, whichever way it is. It's right next to these transistors. This is transistor number Q. There it is, Q3. So Q3 or Q2 or any of these. Q3, Q2. Q3. Okay, so if we look for Q3, Q103. Wow, those. Wow. Is there a Q103 in the list somewhere? Is there a Q103? Yeah, Q103 other way. Isn't this just drive me batty? Q103. We go to audio board. We look for a Q103. What am I doing? I don't even know what I'm doing. You know what? I've gone around in circles too much. I've got a vortex inside my brain now. And it's not helping. Okay, so down to square one. Component side. Of audio board. So, yeah, find it's got to be right here. The capacitor. Well, we can see the connections here, for crying out loud. We can just trace them. So, for instance, let's start with Q102. Shoot down to the thing here. Q102. So this is Q102 here. There isn't another Q2 on this board, is there? Didn't they even do something like that, did they? I'm looking at the other transistors. No. Okay. Q2 right out of here, straight to the capacitor. Oh, wait a second. Oh, okay. I know what I've been doing wrong this whole time. So I just noticed the dotted line. Okay, my apologies. These transistors are not on the board. These are on the board. These are not. The 102 is on the board. The 1 is not. Now, why are these the big transistors on the back? Jim, what happened to your head? And this is actually an output heading to the this capacitor's output heading to the speakers. Okay, I've sort of improved my head. Now these wires, we can find these wires coming up here out of here. This is a good spot. They would want to test every one of these base wires. Every one of these base wires. I've kind of done that, but I did it kind of without, did it early on. I'm not too sure what I was doing there. We need to know which terminal is the base terminal on these transistors. And Is there a diagram of that? I don't think so. There they are. They're numbered. They're numbered here. They're numbered up there. Is this underneath? What is this? Test point. Test point. Yes, test points went through my head a couple of times here. I don't think it came out of my mouth at all, but I kept thinking there must be some test points in this guy. Okay, let's take a look. What is the test point? Test point here and a test point there. Test point here. What is this? These two test points. I don't remember them being talked about anywhere in the manual, but I haven't read it that carefully yet. Okay, well, we haven't got a diagram that's really going to help us thoroughly with sorting out component arrangement around here. And I can probably figure out which one is the base, and we will listen to the base on each one of those guys. We'll listen to the base on each one of those guys. So I would need to determine the... So this is not on the audio board. These are, I got a front panel. Oh. Sorry, I'm jumping all over the place here. Some of these boxes are not named, like this one. It's just got no name. Now I saw the Qs. Where are the Q1, Q2? Just find them looking in the list. Here they are. Here they are. Transistor NPN power. Here we are. What am I trying to find out? I'm trying to find out the number, the type. Oh no, that's right. Well, yeah, that's not going to help me. That's their private part number. Transistor NPN power. So, son of a gun. What appears, well, they're not going to name it on here, in the schematic. Uh-oh, this is not so good. This is not so good. Where are those transistors? Right here, just Q2. And the part number. Company's private part number. How am I ever going to know what this is? A lot of research. Why am I worried? Because I want to know the base connection. I'll have to figure out the base connection some other way. Son of a gun, it just, things are made so difficult here. Well, it's possible I can turn this number into another transistor number. I don't know. Wow. What a schmozzle. Well, we still want to know if this is working or not. So these capacitors are probably easy to find now. They're right on the output of these transistors. That'll tell me which channel. Okay, let's find these, because I know where to look for them now. So what I've found, and I think it would be anybody's experience, is when you start working on something like this, you've never actually seen it before. A lot of it is just getting familiar with the ins and outs of the particular unit you're working on. A lot of your time is spent doing that. Now this unit is still switched on, and I'm looking for transistors mounted up in here, or capacitors up in here. I'm looking for two. How about a little more light this morning? And I'm gonna turn the sound up on my tracer just to remind me that it's operating. Well, there's a fairly big one right there. There's only one though. There's quite a big circular one here. 1400 volts that capacitor is rated for. I sure don't see any big. Oh, the 1000. It could be. It could be. It could be one of these guys. It could be one of these right here. What is it? 1000. Bingo. So these are the output capacitors through which the signal is passing to get to the speaker. Look at the size of those things. That's what you need if you're going to do a transformerless output. Okay, so is that really true now? Are those really the capacitors in question? I can't, 1,000 is a big capacitor. This would be 1,000 only if it's a 3-volt capacitor. It's not. Let me look at the diagram again. There's the layout diagram somewhere. Didn't I see a layout? Yeah. C7, C8. There they are. So we got the transistors here. We got the output capacitors here. I should look for the signal on these capacitors. These two capacitors. Okay. Yeah, it doesn't seem to be anything particularly spectacular about them. It's just two terminals. Let's give it a go. I'll turn the volume down on. Oh, volume's already fairly low on the tracer. Hold on to this, ground away any signal that might be in you. So you should bring yourself close to the item. Holding on to this, you're grounded. But holding on to this, you're grounded. You're grounded, man. Okay, here we go. Might be a big pop on it. Oh, jeez, scare the living daylights out of me here. I try to prepare myself for what might happen so I don't jump. That's the idea. Somebody want to try to explain that? The signal is present here. The other side of this capacitor. Nobody. Aha! We have found the problem. We are getting closer to the problem. So either side of the capacitor, you should hear it. Here's one side. Here's the other side. Now, here's the other one. But on the output side of it, what I assume is the output side, you couldn't have sound on the output side without it being on the input side. What has happened? That's a good question. What has happened? So there's a little tiny capacitor there. Check this out. Signal tracer touching wood. Well, this is really interesting. Never mind the radio. Just a sec here. Put this here. What is going on with this? Well, that's interesting, but I'm going to pursue that some other time. But why my wooden bench is picked up by this? Wow, especially right at the edge. There's some strange thing going on there. Okay, back to what we're actually working on. I'm going to turn the power off. I'm going to remove the clip leads from the balance control since they are not really helping. Okay. We have output all the way, both channels, right to the capacitor, and then we don't hear it. So that suggests the speaker switch, of all things. The speaker switch. Well, if it's getting... No, what am I saying? Hey. Yeah, obviously. I'm losing my mind. That's what's obvious here. Why would there be no signal on the other side of this capacitor? So one possibility is there's a little tiny capacitor in there. That little one. He could be shorted. Let's take a look. Shorts near the output transistors, not good things because there's lots of power there. Okay, some residual voltage. You had a big capacitor here with a residual voltage on it. Let's get rid of that. Bang. Nope, no bang. Okay, how about the other side? So these things are conveying audio signals. They're not conveying DC. They probably, well, they would have a few DC volts across them. I would think, wouldn't they? I think they would. Okay. What's the problem? So this is the terminal. I'm going to use a clip lead here. I'm going to go on the terminal of question, the terminal with no sound. And then we're going to read other side of that capacitor, which connects to this terminal right here. Okay, so it doesn't seem to be a short there. Checking my meter connection. Yeah, okay. Check the reading again. There's a voltage sitting there. Why didn't I see that the first time? What else is hooked up to that spot? There's a green wire. It goes down the back here. Green wire. Goes into a bundle. Comes off the back. Is there anything else? There's a green wire and a capacitor to this. Oh, scared the bejesus out of me. I just touched my tracer thing. Yeah, the power's off. I shouldn't be jumpy. So we could nip that capacitor and see what happens. We could do that. There's a chance the big capacitor itself is shot. It's possible. The green wire disappears into this bundle. Goodness knows which. Well, it might be this one right here. Goodness knows though. And that's headed kind of in the direction of the speaker switches, but let's check out the schematic right around this capacitor here. Right around that capacitor. So we'll look at the schematic first, because that's really all I got to look at when it comes to this. Here we are. Here it is. So one wire, the way they've drawn this, it would be the CAN side of this capacitor. Heading up into, and this is the speaker switch. Reverse, speakers off. So we have a capacitor through a resistor to ground, and this is the capacitor I am seeing. It's through a resistor, 2.5 watt, 10 ohm. So this might be a protective resistor in case this guy shorts. I don't know. It's a heavy wattage resistor though. It's ready for duty. Look, there's another 1,000 down here. C6. C5, 6, 7, and 8. These are in the power supply though. They have nothing. They're not doing anything like these. Well, if the problem... So we get no sound on the far side. I should work the switch, the speaker switch, and see if this doesn't change somehow. So we'll get on the quiet channel and flip the speaker switches around and just see if anything can happen on there. Okay, that's an interesting idea. Not terribly hopeful I'm gonna succeed with that. Now let's look at the switch settings again. So AC on, external speaker, reverse and off, and then straight out would be normal. Straight out would be normal. Okay, so we're going to turn the power back on. We will turn the volume up just a wee bit. Let's make sure everything's doing the same thing it was. Nothing whatsoever. Why nothing? Why nothing? What's happened there? I'm hearing nothing. So the speaker switch is flipped. What happened? Okay, let's just listen for the output here. We know it's here. I didn't have to get close to it to hear it. Why not coming out of the speaker? Why not coming out of the speaker? If you hear it here, it's got to come out the speaker. Speaker switches. I didn't touch them. I must be sleepwalking or something. Switch is normal now. I must have bumped that switch. Okay, so that speaker's going. That speaker's going. Here. What are you looking way over there for? There's nothing over there. Reverse switch. So flipping the reverse switch sends the sound over to this speaker over here. Cuts that one off. And that's speakers off. Oh, I did turn the speakers off. That's right, I turned them off to get them off. Okay. Now, we're going to turn the volume down a little bit. Leaving the speaker switch on. I'm going to try to hear it through this guy. He's pretty loud. There it is. The other terminal. The silent terminal. Silent. Check the other channel. And the other. So for this to be dead, there's only a couple possibilities. One is a pretty hard short on it to ground. Another one is the capacitor is just open inside. The actual capacitor contacts inside the capacitor have broken. So yeah, there's two leads sticking out, but one of them doesn't go anywhere inside the capacitor. They completely nullify the capacitor. That's possible. We could cut the wires away from the terminal and then see if the signal appears. Or if there is a short, then we would see a short on this terminal to the chassis. Power off, power off. If there's a short, we should see it. Of course. Okay, I'm going to turn down my tracer here before I scare myself again. Okay, so we're going to go on the terminal in question. Terminal in question. And the first thing we're going to question, is there any voltage setting on that relative to the chassis? If there is, then it can't be shorted. Chassis. Wow, that looks like a short, eh? That looks like a short compared to the other capacitor. Oh, so smart, Jim. Jeepers creepers. I haven't even drank a lot of coffee yet today. Looks like a 0 volts. Okay, resistance. Oh, there's a touch of voltage there. 2K. What do you say? 18. Who knows what that means? Who knows what that means? Because that's a capacitor, it can have some voltage in it. So, you know, every reading is pretty similar. Pretty similar. So I'm testing beyond the capacitor, so to speak. So again, if the capacitor is open circuited here, those tests make sense, I think. Look at the resistance and flip switches around. Okay, so we'll get on the lead in question. I'm going to put this to the chassis here. Flipping some switches. Now power's off. Here we go. So we're in the normal position. The speaker's off. Well, that's interesting. Speaker's off. Speaker's normal. Speaker's reversed. Speaker's normal. I've had the sound come out of both speakers, so I know the speakers are good, and I know the wires going to the speakers are good, and I know the connection into here must be good. Both speakers have operated. But I'm thinking what I'm doing here is I'm attaching two different speakers to this terminal essentially that I'm reading. And right now I'm reading the speaker resistance. Maybe. Let me unhook one speaker here. I can just do it right down here. I'll just pull one speaker off. I don't know which one it is. Okay, it's off. And we'll throw the switch to the reverse position. Oh, there we go. So from here, I am actually reading the resistance of the speaker. Now I got to put this back in here. So it's really pointing to the big capacitor being a problem. That's really what it's saying now. The big capacitor. So we'll look at how would we check that? Put a capacitor tester on it, but it's in a circuit. It's in the circuit. One wire and one component hooked up. I should remove that from one terminal, and then we can test the big capacitor. I think that makes sense at this point. Could even test the big capacitor. It's a big capacitor. Why can't we test it in the circuit? And it's, you know, it's big. It's big, big, big. I have to get my tester. So I'm going to let the video run for 12 seconds. Okay, I'll use this tester on it. First, let's just make sure there's no voltage left in it. Very sensitive setting on my meter. Should be saying 0. Lots of voltage left in it. Well, what's that tell you? That says something right there, doesn't it? No voltage left in it. Getting different readings. It's just possible that the terminal is making and breaking contact now. This seems pretty good now. There's that 1 volt sitting there. Well, I'll put a short on it. See if we can drain it down to nothing. I'm going to give it a little while to do that. Go drink some coffee. Calm myself down. I seem wound up. Oh, okay. So I'm just a little worried about damaging my gizmo here if there was any significant voltage there, which I very much doubt there is. What do you see now? Gone to 0. Okay, so that's suggesting the capacitor is holding a charge and the terminals are connected. We will see. All kinds of conflicting observations here. What do you say? You hear the speaker clicking. So as a capacitor, so it thinks it's a diode. The reverse current's 11 microamps. You can't see what's on my guy here. No, I don't know what that is. UF. Is that thinks it's the forward voltage drop, 1 volt, and C equals 0 picofarads. C equals 0 picofarads. Well, that's a pretty strong indication that what I suggested earlier is true. That the capacitor has lost its connection. So the next thing to do would be to cut the wires off 1 terminal and repeat the test. Or do more tests. I could do more tests once these are off. So 2 wires in there. I know why I'm feeling excited, because I feel like I'm right on the problem here. And it's, you know, for someone who does this kind of work, it's exciting when you really think you got a tiger by the tail here. 1, 2. Okay, so now there's no connections to the wow, so the can part of this capacitor is soldered very solidly. You can see some up here maybe. Soldered. This one over here soldered right on the can. Very carefully. What's the big deal about the can? Okay, we'll repeat this test. This is usually where my theory falls apart. And I'm back to square one here. I don't know if I can get this on. Oh. Okay, don't go anywhere. Get on there. This time it says it's a capacitor. It's 136 microfarads. The ESR is 150 ohms. And the V loss was 0. So this is suggesting it's okay. Let's try it again. There, that's a good connection. Well, now it says it's 33 picofarads. Picofarads. Let's try a different instrument. Okay, so it's a large capacitor, so I can operate quite a distance from my capacitor checker here. Get some long leads for it. This is a low voltage capacitor. This is a high voltage tester. This is not the right board. R. Shoot. Cord that'll reach. There's got to be a polarity to this thing. Negative is the triangle. Yeah, right. Negative is the triangle. Okay. Negative is the terminal that I removed everything from. Negative, positive. This thing says it's a 35 volt, 40 volt, 40 volt, 35 volts, 40 volts. So my tester minimum test voltage is 50 volts. Don't think that's really a problem. Maybe the first thing we'll do is we'll try to measure its capacity, because that's a lot. I'm not putting any voltage onto the capacitor. It's supposed to be 1,000. That's how high this goes. This goes to 1,000. So I'm looking for is the eye to pop open. It need to be on here. There we go. Pop, 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 pop open. No, no. No response. Plugs are in. How do I know these wires are good? And the clips are on. So we'll see. Is it a really small? Is it going to respond as a very, very small capacitor? Very tiny. You can't really see it, but there's actually an effect there. But on this device, when you're at the limits, sometimes the eye operates anyway. Well, it's showing 0 capacitance. That's what this is showing. We're going to put it on 20, it says 25 volts here, but it's actually 50 volts on here, DC. Well, why is this partially closed already? It should be open wide. Yeah, what's going on? Okay, so here we go, 50 volts. So the eye popped open like a bullet. If bullets can pop open, they would pop open quickly. It's a quick operation. There's no way this capacitor was charging up. It would take a long time for that device to charge this capacitor, and it went like that. So I think now we've got a number of indications that this capacitor is defective. So the next way is to parallel in a good capacitor, a little tricky in here, and see if that doesn't fix things. So we need something like 1,000. Like 1,000. We need 1,000. You think I got 1,000 microfarad capacitor laying around? Okay, here's what I found. Let's see. This one is 1,000 at 200 volts. So looks brand new. There's another one. Look at this one. This is a beautiful gold color. Ooh, money, money, money. 10,000 at 71 volts. 10,000 sounds like a little bit of overkill. Wow, 10,000. That's a fairly small package. 2,000 at 20. That's too low a voltage. Yes, big honker here. 1,000 at 180. Negative is the black terminal. So either one of these, it's obvious this would be the one to use. You know, this has to be positioned inside the unit here somewhere. It can be almost anywhere, I would think. Sticking it right up where it belongs would be the best place for it. And removing this one. This one is soldered in place. Some very heavy chassis soldering going on to solder this guy in there. That guy there. So I think he's better left alone. We'll leave it on the top. It'll look proper and correct. We'll disconnect it underneath and we'll install this one somewhere else. Where else? So you know, somewhere. This is heavy. It needs to be strapped in pretty solid. The wires can be quite long coming back and forth from this. This is an audio level thing. Having extraneous signals get on longer wires, that won't matter. Like you couldn't do this in the radio, of course. You couldn't move a component a distance in the radio circuit, or you'd certainly introduce problems. But and it's got to be thought about for a while before I go ahead and do it. Oh, you know what we can do? Turn off the checker. We can do a temporary test with this. Yes, let's do that. Let's do that. Now, the trick here is I've got a couple wires disconnected up here. We should probably not test it without all the wires. So let's get a couple of clip leads here. Okay, from the top terminal, that would be the positive one. Whoops, I'm using two white clip leads. We'll go there, like that. And the other one, I'm going to turn off my signal tracer here. The other one, so there's a wire that leaves that terminal, which now switches off. Yep. Don't even need to use a clip lead. There we are. This is the wire. Just twist it on there for now. Is that going to be good enough? That was a little interesting. A little sound out of the speaker there. Okay, that's going to hold on tight. And now we got to engage this capacitor up here. I'm just going to throw a clip lead up to it. Which is probably not the best way of doing it. From here up to here. Capacitor. Okay, so now we think we're ready to make sound come out of both speakers So I want the radio playing, and we just work the volume, the bass, the balance control rather, back and forth, and we should just hear the sound go back and forth and rejoice. If there's any voltage here, it's tiny. Not going to worry too much about this being hooked up backwards. I'm pretty sure it's okay, but my pretty sure isn't all that sure, in fact, so I've learned. Any reason to hesitate further? No. Okay, so volume control set up a little bit. Balance control, I'll try to set it in the middle. Okay, so I think that's in the middle. Flip it on, we should hear it. Here we go, flipping it on. Balance control. That channel. That channel. Okay, so that's it. That's the problem. Yeah. That made the right sound there. Okay, so now it's just a matter of permanentizing this arrangement here. Permanentizing the arrangement, and then we're on our way to checking the quality of the radio receiver and stuff like that. That's great. I still have my option. I could put this guy in. No, I couldn't. This guy in. Now, go for the small one, the one I know is working. Do I know it's working? Okay, so hold on. One last thing. Did I check this on my tester? Come off. One more thing. I'm anxious to get outside here. My cats are probably wondering what the delay is today. Because from here I usually grab my coffee and I head out. Well, that was kind of odd. This thing just triggered itself. She's testing away. So you can see it says 900 microfarads. That's perfect. That's perfect. It's supposed to be 1,000. What's 100 microfarads between friends? Well, that's great. Okay, so managed to nail it down. Good day in the shop. Thanks a lot for watching, and tomorrow we'll carry on. See ya.